one word. Mean is average. Average. Median is middle. And mode is most frequent. I don't know how you want to. And those are the ones you've been doing for years. And truthfully, when a set of data numbers are normal, those will typically be in the same ballpark as each other, right? You'll get some weird cases and outliers that sometimes will pull the average higher than it really is. And a lot of times when you read stats, you're reading facts, but you're reading what supports the person's cause. So, for example, if you're a politician and you want to argue that people are making an appropriate income, right? That income levels are high enough to sustain cost of living, basic cost of living, you'll probably pull the average income number. Because there's a few rich people that make billions of dollars that will pull that average up, and it will make it look like a better situation than it really truly is for most people. Does that make sense? So if that's what you want to argue, you'll probably say, well, the average salary is, $100,000, when in reality, without those billion-dollar people, it would have been $70,000. Do you follow? And then someone who wants to argue the opposite might use the median or the mode. They might just say, because the middle kind of takes the total top earners and the total bottom earners out of the equation. You just find out where the direct middle of all these people is. So they would probably use that because that would probably be a little bit lower in the example I'm giving you. Or they might use the mode. Like the most people are falling in the $40,000 to $50,000 range, something like that. Even though the average is $100,000, but most people are falling in the $40,000 to $50,000 income range. So you have to be careful when you read anything. Not that anyone's lying to you, but they're telling you the number that fits their argument the best, especially if they're trying to persuade you of something. Does that make sense? Okay. The one thing that you've done before, and I was just doing this with an Algebra 1 kid, so I know you did it in Algebra 1. He was calculating the standard deviation. He had no idea what it meant. No clue. He knows how to type numbers into his calculator. He knows how to grab a number off of it, but he has no idea what it means. Does anybody know what a standard deviation means? Yep. You're doing great. You can get even more specific than we need to. At a very basic level, we need to understand standard deviation as the amount of deviation of a set of data. So it's the amount of deviation, which, if you need a synonym for that word, the amount of variance. Variance would be like how much the numbers are varying. So I gave him an example of two students. Student 1 got these 5 scores on his 5 tests. And his average was what? What's the average? I tried to make that easy for you. 85, okay? The other student got an 85, a 95, a 75, a 70, and a 100. So what's his average? 85. So if you just present their averages, it looks like, okay, same type of student, but really not the same type of student at all. What would you say about this student versus this student? This student is more consistent. Standard deviation is a measure of consistency. The lower it is, the lower these numbers deviate, the less they deviate, the more consistent you are, okay? So you can say measure of consistency. And the lower your standard deviation, the less your numbers deviate from your average, the more consistent you are. So lower equals more consistent. So we will be looking at standard deviation a lot. And it would certainly help if you knew what those numbers meant. So even though the averages and the mean and the median and the mode would all be, these population parameters would all be around the score of 85, right? The mean, median, and mode would all be around 85, but the standard deviation would only be like 1 or 2 here, versus the standard deviation here would probably be like 10. Does that make sense? The standard deviation is not like a score that would potentially fall on the list. It probably won't even be in that ballpark unless it's coincidental, but it kind of gives you a feel for approximately how much these 5 scores are varying from each other. So these are 1 to 2 points. These are 10 to 15 points of variance. Okie doke? All right, so the example I just gave you a great example based on averages and tests, but for you fantasy football players in the world. In 2012, the top 2 fantasy football wide receivers based on fantasy points per game were Marvin Harrison and Terrell Owens. So they both scored 14 points per game. So that's probably the statistic that your average person is going to look at because they don't know any better, right? But a statistician would be like, okay, well, they score the same on average, but one has a standard deviation of 6, is that? And the other one is 2. So who is more consistent? Terrell Owens. So the standard deviation of data gives a measure of consistency. It indicates how spread out the data is. So Terrell Owens appears to score 14 points, give or take 2, most of the time, right? Whereas Marvin Harrison scores 14 on average, give or take 6, most of the time. Yes? So if you are in a position to play with one of these players and you only have one spot in your roster and you need someone to have like 14 points, and that would be, you feel like that would be good enough to get you a win, you're probably going to play Terrell Owens because he's more consistent with getting about that number. If you need someone to score 20 points, I mean, even though Marvin Harrison could score only 8 points, he's the one that has more of a potential to have a great game, right? He's probably not going to score 20 points, right? He pretty much mostly scores anywhere between 2 below this, which is 12, and 2 above it, which is 16. So he's probably not going to ever score 20 points. It's going to be very rare. And even though he could do really poorly and score as low as 8 points, he might score up to 20 points, a little bit more likely than Terrell Owens would. So sometimes that lack of consistency and the potential to have a great game is something that you would capitalize on. Yes? Okay. So a given player scores within 1 standard deviation of his mean 68% of the time. That number is not changing. So, and that's why I just kept saying most of the time. Most of the time, 68% would quantify as most, right? Anything over half is a majority of the time. So most of the time, which that will always be 68%, you need to memorize that number. You're going to score within 1 standard deviation of your mean, okay? So for Marvin Harrison, if I jump down, Marvin Harrison scores within 6 points, because that's his standard deviation, of his mean, which is 14, 68% of the time. That means Marvin Harrison, 68% of the time, is scoring between what 2 numbers? 1 standard deviation below 14. What's 6 below 14? 8. And what's one standard deviation above 14? 20. Okay? We can go out 2 standard deviations. And if we go out 2 standard deviations, that's this next sentence. So 1 standard deviation is 68%. 2 standard deviations, 95% of the time. So with 95% confidence, we can say that Marvin Harrison is going to score, so I'm going to up it to 95% of the time. He is scoring between, if 1 standard deviation is 6 points, what's 2 standard deviations? 12. So what's 12 points below 14? 2. That would be his worst game. And what is 12 points above 14? 26. So 95% of the time he's scoring between 2 and 26. Yes? Does that make sense? And that leaves just 5% of the time to go have a really, really terrible game and score 0 or 1 point, or a phenomenal game and score more than 26. Okie doke? But our standard deviation gives us kind of a window of likelihood. So that second space would be he scores within 12 points of 14, 95% of the time. And that's give or take 12. Terrell Owens scores within, now his standard deviation is 2 points of 14. So what would that window range be for 1 standard deviation, Jack B, for Terrell Owens? 68% of the time he scores between what 2 numbers? No. He's got to be within 14 by 2 points. So what's near 14 within 2 points on the low end? 12, and on the high end? 16. So that's 2 above and 2 below. And that's 1 standard deviation for Terrell. That's 2 points. 2 standard deviations would be 4 points. So what would that window range be, Angie? 95% of the time he's going to score between what and what? Perfect. That 4 below is 10. 4 above is 18. So back to my point from before. If you needed someone to have a 20-point game, Terrell Owens is not your guy. We love that he's consistent, and if we need 14, we're going to play him. But if we need someone to have a knockout game and score 20-some-odd points, you do just have a better chance with Marvin Harrison. It can go really well, or it could go really bad, but at least you kind of have a chance with him. Whereas Terrell Owens only really scores up to 18, 95% of the time. Good? So here is a normal curve. Okay? That's a normal curve where the average would be kind of in the middle. And then we'll look at kind of spreading out the standard deviations on this. But what your curves will look like with a small standard deviation versus a large standard deviation. If you are Marvin Harrison, we'll do that. And you have a bigger standard deviation, your curve spreads out more. I'll put MH on this. So the perfect normal curve is the one that was already there for you. But if you have a larger standard deviation, your curve kind of flattens out. Whereas if you're Terrell Owens and you have a smaller standard deviation, your curve is going to get taller and skinnier. Because when we talk about that 95%, we're kind of talking about the area under the curve. So 95% of the area under the curve for Marvin Harrison is spread out much further with a lower curve. Whereas 95% of the curve for Terrell Owens is much more concentrated towards the middle. Does everybody see that? If you looked at the space under the curve, 95% of Marvin Harrison's area, and we'll say that this bottom empty space and this top empty space equates to the additional 5%. There's 95% of his time versus Terrell Owens is much more tightly squeezed. Do you follow? So the taller and the skinnier a curve, the smaller the standard deviation. Good? Any questions on that? Flip to the back. Actually, have your calculators out. We're going to actually throw that data in the calculator. As a reminder, putting data in the calculator. You have a stat button. And our stat button, when you hit it, brings us to this screen. We want to edit our lists. I currently have nothing in there. If you guys have something in there and you want to clear it out, you have to scroll up to L1, which stands for list 1. And once you've highlighted list 1, all your numbers should show up on the bottom. But if you hit clear, they'll clear out on the bottom, and then once you scroll back down, they should all disappear. So let me make sure we can all get rid of whatever data is in there first. If you're having trouble with that, just walk up here. Once you've gotten rid of that data, we're going to put in these quiz scores from this person's class. Did someone just say they're so confused? No? Okay. 56, 68. Just enter those in. One of the biggest things, and I'll just talk while you're plugging these in, that I notice that people make mistakes on, it's very frustrating, is they just mistype in a number. Or they skip one. It's very frustrating. So make sure you don't miss anything. Glance over your numbers and make sure they're all in the right ballpark once you're done. And then just to make sure you didn't miss one, or maybe inadvertently type one in twice that wasn't supposed to be typed in twice, if you highlight your last number, down below you'll see it says list 1, and then in parentheses it says 18. That means that's the 18th number on my list. And there are 18 students here in his class, so I know I've typed in all 18. So number 1, make sure you've typed in the right number of numbers. If you go down to the next empty row, it's going to say 19, because that's the 19th person. You shouldn't have anything there. So make sure you have all 18 scores in, and then just look at them, make sure you didn't mistype anything in, okay? Once you have that data in there, and sometimes you guys might remember this from Algebra 1, you would use a second list to represent the frequency with which each score is happening. But we didn't do that here. If there were two 100s, we treated them as two separate data points. Sometimes we will get to frequencies, and we'll use the second list for frequencies, okay? But not here. We just have our list of numbers. Then hit stat again, and then rather than editing this time, because we already have our list the way we want it, we scroll over to calc, and this is going to calculate a whole bunch of things for us, okay? So we're going to calculate one variable statistics almost all the time. The list from which we want to calculate these statistics is list 1. Like I said with the frequency, we didn't have a frequency list here, so that should be empty. Keep it empty. And then hit calculate, and you have a whole bunch of stuff. Okay? The stuff that's important to us, X bar, what does that mean? X bar means average. And that number for this particular one is 83.7 with a 2 repeating. The next two numbers, this little sigma notation, x, what does sigma mean? Do you remember? Sum. That's just adding all of the scores together. We're never going to use that here. This one is taking all of the numbers, squaring them, and then adding them together. There's a use for that in like advanced statistics. We won't be using it. These two numbers both stand for standard deviation. So the S with a little subscript x, you can't tell in your calculator it's a subscript, but it is. That is your sample standard deviation. And that is 12 we'll just say 0.05. And then your other one is this little Greek letter. I can't remember what it is. Does anyone know what that is? That's a Greek letter of some sort. Omega, maybe? Who cares? We've got the symbol. That's your population standard deviation. And 11.71. And every year I forget this. I'm gonna double check with they'll usually say what is the sample standard deviation, in which case use that, or they'll say what is the population standard deviation. Okay? What I can't remember is which one is the actual calculated standard deviation for this set verbatim versus I think the standard deviation for this set, and I'll double check on this, if it mattered a ton, I would know it, so don't overly worry about this. But the standard deviation, if I were to calculate it by hand, I'm pretty sure for all of these numbers would give me the samples number. This one kind of says, okay, well, if this is what our sample says, and usually samples have a higher variance than the overall population does, this one kind of translates it to, if we were talking about it like an infinite population, what would it vary by? So I'm going to get back to you on that. I got to double check. I do this every year. And every year I'm never happy with the answer I get because it's confusing. And so I don't even know why I try to explain it to you guys when I can't really fully wrap my head around it. But I'll try again. I'm hoping after many years it will sink in. But if they ask for sample, you give the S sub x. If they ask for the population standard deviation, give the omega sub x. Okie doke? They should make that clear. If they don't, I'm pretty sure we who grade it take either or. Okie doke? What does N stand for? What's 18? The number of data points we're looking at, 18 kids, so hopefully you know that. And then these next 5 you did a lot with in Algebra 1. The min, the Q1, the median, the Q3, and the max. Those 5 numbers you probably called a 5-number summary or a box and whisker plot. Do you remember those? Okay. That's what those 5 numbers are. I've never seen a box and whisker plot on this regions. I haven't. It is a basic data thing though, so if it came up, I'd feel bad if I didn't review it with you. So those 5 numbers pretty much tell you, create a number line from 50 to 100. Make sure your number line gets lower than the low and higher or as high as the high. So I'm just going to do 50, 60, 70, 80, 90, boy, I really got lucky there, and 100. And make sure your number line is scaled properly. Don't put 50 and 60 right next to each other and then put a humongous gap between 60 and 70. Part of what you grab from a box and whisker plot is the spread of the data. Really, the standard, another way of checking on variance. A box and whisker plot really helps us see different variance. So your minimum would be 56. and I put that number there. 56 would be about there. Q1 is 75. Median is 84.5. 93 is Q3. I don't know why you guys hate these so much. You literally just copy down numbers. I was surprised by the sound effect I got when I said that word. And then of those 5 numbers, a whisker comes in from the bottom, a whisker comes in from the top, and then a box goes around these, and then that line goes down the middle. So it kind of shows you the spread of the data. Yeah, no points around these parts. So what 25, if you took all of these 18 people, the top 25%, and I do this a lot with your score, the top 25% of people scored between a 93 and 100. The bottom 25% of people scored between 56 and 75. No offense to the 100s of the world, and no offense to the 56s of the world, but you probably don't do your work, so who cares? I can't really help you. These people are going to get it with or without you. What we really care about in stats is the middle 50% a lot of the time. Because if the middle 50% scores between a 40 and a 60, there's a problem. I don't care if someone scored 100. That person's a genius, they're going to be fine regardless. But this middle 50% scores between a 75 and a 93. And then it further separates the upper middle class from the lower middle class. Yes? So it kind of gives you the spread of that data, just like standard deviation does. Okay? C is what I'm talking about. What was the population standard deviation? That was 11.7. Okay? So what that means, how do you interpret, and this is huge, you're going to write this phrase 1,000 times this chapter. It means that 68% of the time, students scored within 11.7 points of the average. That means 11.7 points above whatever the average was. So average plus or minus 11.7. That will give us a window, just like we did with the fantasy football example. The average was 83.72. So that would be 83.7 plus or minus 11.7. We'll go 11.7 points above that and 11.7 points below that. And that's the window that 68% of the kids scored in. Does that make sense? Okay? So you're going to be writing a phrase like that a lot. 68%, you have to know that number as being one standard deviation, and 95% if you ever talk about 2 standard deviations. All right, here comes your homework. Lucas, you can go down to counseling as well. Fill that out. Just a quick word of caution. It's even easier to fall asleep this chapter because there's not as much handwritten work. Yes? However, if you fall asleep and miss these explanations and zone out, it's like 10 times harder to rewrap your head around what the heck is going on. Capiche? It'd be like trying to jump into Shakespeare on chapter 10. Like you have no idea what's going on.
I can't do that on the first chapter.
Of Shakespeare?